I am R. Prabha, Assistant Professor in the Department of ECE, SNS College of Technology. In this video, we will discuss the topic on gain and directivity measurement for the course Transmission Lines and Antennas. So, measurement of antenna gain. Gain is the ratio of maximum radiation intensity of test antenna to maximum radiation intensity of reference antenna. So here the radiation intensity is defined as the power radiated from an antenna per unit solid angle. Basically, during gain measurement, there are two standard methods are used. One is called absolute gain method and another one is called comparison method. So absolute gain method is classified into two types. One is two antenna method and second one is three arbitrary antenna method. So in two antenna method, the input of the transmitting antenna is adjusted to an appropriate level and the corresponding receiver reading level is recorded. The attenuator dial setting and the power bridge are recorded. Say it is as WT and PT1 respectively. And this picture shows the diagram of absolute gain of identical antenna measuring setup. So it consists of receiving antenna on the left side and transmitting antenna on the right side. And the receiving antenna is the antenna under test. And with the receiving antenna, attenuator pad is available and the receiver detector indicator is there. And at the right side with the transmitting antenna, we have the attenuation variation and the calibrated attenuator and the modulation process and detector is available. So now the transmitter in this setup is disconnected from the antenna and it is connected to the receiver through pads. And the attenuator dial is adjusted until the receiver reads the same previous levels. The attenuator dial setting and the power bridge readings are noted as WR and PT2. If PT1 is equal to PT2, then no correction is needed. If drifting power is involved, then the correction is needed. And in the gain measurement, a very famous formula, Friss transmission formula is used. According to this formula, power received PR is equal to PR GT GR lambda by 4 pi R the whole square. So here PT is the transmitting antenna power and GT is gain of transmitting antenna, GR is gain of receiving antenna, lambda is the wavelength, R is the distance between the antennas, PR is the received power. So Friss transmission formula describes the received power with respect to transmitting antenna parameters. And in this formula, wavelength lambda and the distance between the antennas are also involved. So, in this method, if two antenna is identical, then the gain of transmitting antenna and gain of receiving antenna in decibels is same at both sides. So, the gain decibels is calculated from the formula as 1 by 2 20 log 4 pi r by lambda plus 10 log p r by pt. And this is two antenna method. Now coming to three antenna method. Suppose if we do not have two identical antenna, we can use three different antennas of gain G1, G2, G3. And here there are three formulas are involved, the three expressions. So here G1 act as transmitter and G2 act as receiver. Then G1 of dB plus G2 of dB is equal to 20 log 4 pi r by lambda plus 10 log pt2 by pt1, pr2 by pr1. So this is from the Friss transmission formula. So, but G1 act as a transmitter and G3 act as a receiver, then G1 decibels plus G3 in decibels is equal to 20 log 4 pi r by lambda plus 10 log p r3 by p1. This is equation number 2. Here then when G2 act as a transmitter and G3 act as a receiver. In this case, G3 of dB plus G2 of dB is equal to 20 log of 4 pi r by lambda plus 10 log of p r3 by p r1. So this is equation number 3. So the three equations are involved. By solving these equations, we can get G1, G2 and G3 and three unknown gains of an antenna. And next method is measurement of gain by direct comparison method. So in this method, primary antenna is the antenna under test and the secondary antenna is the transmitting antenna. The distance between the two antennas are made as r is equal to 2d squared by lambda. And this primary antenna is connected to the receiving antenna, and there is a horn antenna with a switch is involved. The switch is connected with the antenna under test and also the horn antenna, and at the this side and we have an attenuator and a receiver detector, and with the secondary antenna we have attenuator, signal sources and also modulation setup, etc. And the first standard antenna connected to the receiver with the help of switches. The input of the transmitting antenna is adjusted to a convenient level and the corresponding readings in the receiver is recorded. The attenuator dial setting and power bridge readings are also recorded. Say it is as W1 and P1 respectively. Now connect the test antenna whose gain is to be measured in place of standard gain antenna. The attenuator's dial is adjusted